Hey, we are covering section 3-1 today, and we're talking about quadratic functions. Quadratic functions are polynomials that have their highest power is 2. So a lot of times we write them in this form where a, b, and c are numbers. And what we're going to practice in this section is taking this form and writing it into a different form, standard form, which is y equals ax minus h squared plus k. So we're going to practice taking this and writing it this way, and there's a technique for that. It's called completing the square. So what I'd like to do is write a list for how to complete the square and work a problem alongside that list so you can see how it works as we go along. This list is something that you should put in some form on a note card and you should memorize. So when I say complete the square, you should have a game plan or a list that pops up in your head of what to do. The first step is you want to move your constant term, that's the number that's sitting by itself, over to the y side. All right, so let's get an example running over here. Okay, so what this first step is saying is take this 5, which is your constant term, and move it over to the other side of the equation. So that'll make this y minus 5. We subtract it from both sides. Okay, so that all you have is x's on the right side. The second step is you're going to factor out the coefficient of the x squared term. So what that means, the coefficient of the x squared term, that's the number in front of the x squared. That's what coefficient means, the number in front of. So I'm going to take that out of the whole right side. So factor the coefficient of the x term out of the x side, let's say. It doesn't have to be on the right, but I usually try to put it on the right. So that's going to look like this. The 2 comes out front. That leaves an x squared and a 6x. And you're going to leave a little space in here, in that parentheses. We're going to fill some things in there. Now, one of the things that I'm going to try to identify pitfalls along the way. I realize that on this right-hand side, you have an x squared and an x term. So a lot of people are tempted to also factor out an x out front. And while that is legal, it's not helpful. So that is not something that you want to do. All you want to take out is the number and leave the x's, because what we're trying to do is create a quadratic in here. So we want to keep the squared term inside. Okay, next step, you're going to take the coefficient of the x term, not the x squared term. You're going to divide it by 2 and you're going to square it. And that number you're going to add inside your parentheses and on the left-hand side. Okay, so let's take a look at what that looks like. I'm going to take my coefficient of my x term, which is the 6 here. I take the 6, I divide it by 2, and then I square it. So 6 divided by 2 is 3, squared is 9. And 9 is the number that I'm going to add into these parentheses here. Okay. Now, the tricky thing is I added that 9 into the parentheses. So look at this. That means that this 2 is actually multiplying by the 9. Do you see that? If we were to take this 2 and distribute it back in, what would really have happened is that we would have been adding 18 here because the 2 multiplies by the 9. So what I did was I added value to the right-hand side of the equation. So in order to keep the equation balanced, I have to add the same amount to the left. You can't just go adding things to one side of an equation. So to compensate for that 9, I'm going to add 18 to the left-hand side. Why 18? Because the 2 times the 9 is really a plus 18 on the right-hand side. So what I'm going to write over here in the instructions is I'm going to say in parentheses, compensate for the factored out number. Okay, what that means is the 2 multiplies by the 9. Now, I'm writing these instructions kind of in my own language. You need to do the same. So if that language, if you don't like that language and you want to use some kind of different way of explaining that to yourself, then that's what you put on your note card and that's what you memorize. Okay, the next step is we're going to simplify and factor. All right, so that means we're going to add some things up. So I've got on this left-hand side, I've got negative 5 and a positive 18 is a positive 13. And then I've got the 2, just get this down a little. Got the 2 out in front, and then I've got the x squared plus 6x plus 9. And I'm going to factor this. And it always factors. This is, I mean, you should be able to factor this without any tricks. But it turns out that it will always factor as this number that you squared. So this guy and this guy will always match. Now the reason that trick is helpful to realize is that there will be some problems as we go on where this quadratic factors with fractions. And sometimes it's easier with fractions to go to the trick instead of actually trying to factor it out. Okay? And then the last step, step 5, is to add the constant, or let's just say move the constant, because sometimes you subtract it. So move the constant back over. All right, so that means I'm going to subtract over the 13. And this is, if you look up here, this is your standard form. Okay? So that's how you get something in standard form. Now the question is why? Why do we care? Why would we do that? Well, look at this. If I ask you to graph this equation right here, I mean, you'd have to maybe plot some points and maybe you calculate some x-intercepts using the quadratic formula, some things like that. But if I ask you to graph this right here, you should be able to do that. Let's review from chapter 2 stuff. Here's my axis. My parent shape is a parabola, and it's got a slope of 2. So it's a little bit steeper like this. Okay. And then I am shifting left 3 and down 13. So left 3, and we'll pretend that this is 13. Okay, I don't want to count all the way down there, but down 13, and there's my graph. So I'm able to see the shape easier and quicker when it's in this form. I also think it's easier to calculate your x-intercepts in this form. So we're going to go through kind of some details that we might want to find. So the first follow-up question that, well, I mean, obviously the first homework questions would be put this in standard form and graph it, which is what we just did. And we'll do a couple more examples, but follow-up questions could be, what is the vertex? Okay, the vertex is a vocab word, and what that is it's the minimum or maximum point. Okay, so in this case on the green graph we have a minimum point, and that point occurs at 3, comma, negative 13. If it was turned upside down, we'd have a maximum, and the vertex would be that maximum. Notice also an advantage of this standard form that my vertex, 3, negative 13, is the shift on the graph. So you actually can name the vertex without even ever drawing it, as long as you make sure, oops, sorry, there's a typo there. I meant to write this as a negative 3, okay? As long as you make sure to change the sign on that 3. So I can ask you what the vertex is. Other questions that your homework might ask you are to find the x and y intercepts. So let's do that one at a time. X-intercepts. If you don't know how to find the x-intercepts of a graph, you need to make a note card. And what you're going to put on the front is x-intercepts. And on the back, you're going to write plug in 0 for y. Why do we do that? Well, let's talk about an x-intercept. We've got some graph like this. Here's the x-intercept, and here's another x-intercept. What do they have in common? Their coordinates have the fact that it's something 0. So that means that they are the places where y equals 0, which is why we're plugging in 0 for y. So it's not all memorization. If you understand the y, you don't have to memorize it, but you do have to somehow connect with how to calculate it. So I'm going to plug in 0 for y. So I'm going to take this standard form that I calculated, y equals 2x plus 3 squared minus 13, and I'm going to plug in 0 for y. I'm going to want these answers in exact form. So you can calculate these on Class Calc to estimate your answers and tap on the x-intercepts and estimate the answers to check, but I want them written in exact form. So I'm going to add over the 13, divide by the 2, and then I square root both sides. Now when you square root both sides of an equation, you have to put plus or minus, and then you're going to subtract the 3 over. So I get minus 3 plus or minus the square root of 13 halves equals x. These are the x-intercepts. And if you put them in decimal form, they should match what you see on Class Calc. You've got negative 3 plus that square root and negative 3 minus that square root. Okay, that's the x-intercepts. The y-intercepts. What do the y-intercepts have in common on a graph? Well, they're always a 0, comma coordinate. So what do? How do you find them? You plug in 0 for x. So again, I'm going to take my equation and I'm going to plug in 0 for x. Now I'm doing it the long way first. I'll show you the quick way in a minute. Okay, there you go. This is the one time where standard form is not advantageous. Let's look at this equation in its original form. It was given to us up here. I'm going to box it in, oh my gosh, struggle. Okay, right here. Okay. Plug in 0 for x here. 0, 0, 5. Okay, and that's what we calculated was 5. So sometimes it's easier to look at this form, and sometimes it's easier to work with this form. And you get to choose which we do. But that's the quick way of getting y-intercept of 5. Okay. The other thing that we'll want to do on these problems is find the domain and the range. So let's go back up here to do that. So we can look at the picture. It's the green that we're looking at. Domain. Domain on a parabola is always all real numbers. Our shorthand for that is a double bar R. That means all real numbers. You can also write negative infinity to positive infinity. That works too. And then range. The range turns out it's all the y values that the graph encompasses. So as I'm drawing y equals lines, which are horizontal lines, when do I start hitting the graph and when do I end hitting the graph? That's the idea. So I start right here at negative 13 and I end never. This graph goes up forever. So this is negative 13 to infinity. Another way to think of it is it's always the vertex up or the vertex down, depending on which way this thing's turned. So that's the quick way to do that. And the other thing that we might want to do is find the min and max values, which really is just the vertex. So that's just an issue of vocabulary. Okay, so those are all the details that they'll ask in the homework questions. Let's go back to completing the square and just try one more problem, okay? I'll do a little bit of a harder problem so you can see what that looks like with fractions. This is probably as bad as it will get, okay? So if you can do this one, you can do any of them. So first thing we're going to do, I'm following the list that is in my head that you need to memorize some form of so that you have a game plan. Subtract the 1 over. So y minus 1, that's my first step. Then I'm going to factor out the coefficient of the x squared term. Okay, so negative 3 is going to come out front. And the way that you factor something out, well, let's look at this over here. Let's say we were looking at 2x squared plus 6x, okay, and you were factoring out the 2. Most people can see that that's going to be 3 that's left over. But what's really happening is I'm taking this 6 and I'm dividing it by 2. That's how I'm getting the 3. So when you're not sure what factors, I'm taking a negative 3, how does that factor out of a negative 5? All you're doing is dividing it. So what's negative 5 divided by negative 3? Well, that's a positive 5/3 x. Okay. Then we're going to take this middle coefficient, the 5/3. We're going to divide it, we're going to divide it by 2, and we're going to square it. So in fraction land, dividing by 2 is the same as multiplying by a half. So we get 5/6, we square it, and we get 25/36. That is the answer, the number that's going to go in here. Okay? Now, we need to add an equivalent thing to the other side. How do we do that? We take the negative 3 and we multiply it by the 25/36, and that's what we're going to bring over onto the left side. So let's do that over here. Negative 3 over 1 times 25/36. I can cross cancel before I multiply if you want. You do not have to. You can reduce later. And that's going to equal negative 25/12. So that's what I'm going to put on the left hand. On the left hand side. Okay, then we're going to simplify up. Negative 1 minus 25/12. All right, scratch paper down here. Negative 1 minus 25/12. So I need a common denominator. So this is going to be negative 37/12. Okay, and then I'm going to factor the right-hand side. This is where the trick comes in super handy. How does this factor? Well, it factors with an x, and then whatever this number is what goes in here. So this is going to be plus 5, 6. If that was a negative number in there, I would have used a negative. And this is in standard form. So super ugly, lots of fractions, but you're still going through the same list, and as long as you do your computations carefully, you'll be in business. I want you to stay in fraction land with these. I do not want you to go decimals. So now I could answer some questions. I won't go through all the x-intercepts, but the y-intercept is easy. It's 1. And the vertex is also easy. That's going to be negative 5, 6. Oh, whoops, we didn't add the 37 twelfths over. Let's do that. Sorry about that. Add this guy back over. That's our last step. There we go. It's important because you want to get the right sign on your vertex. So vertex is negative 5, 6, comma 37 over 12. Remember, you change the sign of the guy in with the x. You keep the one outside the same. Okay. If I wanted to graph this, this would be shifted to the left 5, 6, down 37 twelfths, and it has a slope of 3, and it's flipped down. So you can sketch a graph of that. Okay, really focus on completing the square. We will end up using that again in trigs, so this process is really important for you to get down now. And I'll see you